In number 4, we're asked to examine a system of equations and figure out a bunch of different values for m, p, and q in different situations. So situation 1, letter A, we want to figure out what the values of m, n, and p are such that the two planes are coincident. In other words, they're complete scalar multiples of each other. So I have to find a variable that I know the ratio between them. So z's pretty easy. 3 times 2 makes 6, and the same is true for the x's. X times 2 makes 2x. So if I want to figure out what m has to be, m has to be 1/2. And the reason I know that is there has to be a double between here and there. So 1/2 times 2 makes 1, or 1y. Okay. The p and q relationship, well, p has to be double q, whatever they happen to be. And that's kind of why they're asking this question down here. Are the values unique? Explain. Well, no, they're not. They're not unique because I can pick any value of p I want, or q I want, as long as they follow this relationship. Okay. Any value of q will produce a different value for p. Okay, so that's not unique. The m has to be 1/2, but the p and q ones are related to each other. Okay, let's look at letter B. Just get rid of this piece. Determine values m, n, and p such that two planes are parallel and not coincident. So again, I need my normals to be scalar multiples. So for part B, m still has to be 1/2. I need the double relationship to happen between these pieces, and these pieces. But I do not want the doubling to happen between p and q. So p cannot equal 2q. And again, asks, are these unique? Well, no, again, not this time. Okay, no. Any values that make this equation true are possible. So for instance, I could have, I don't know, q being 5 and p being 6. Well, that's not double. Or q being -3 and p being +17. That's not double. So there's lots of different values we can have there. Okay, let's look at letter C, a different kind of question. Find a value of m such that the two planes intersect at a right angle. Right angle, well, we know that as perpendicular. So our two planes are going to intersect at right angles. Then the dot products of our two normals have to come out to 0. So let's write down our dot products. Sorry, our normals. So normal number 1 is 2, 1, and 6. Normal number 2 right now is 1, m, and 3. Okay. If they're going to meet at a right angle, then n1 dot n2 has to come out to 0. So what do we get? We get 2 plus m plus 18 equals 0. So I get m plus 20 is 0. In other words, m is -20. This one says, is this value unique? Well, yeah, it has to be. It's the only value that makes these two normals come out to a right angle. Yes. This is a unique value. There's no other number you could put in for m such that the dot product comes up to 0. Not possible. Okay, last one. Determine values of m, n, m, p, and q such that the two planes intersect at right angles. Are these values unique? Well, we already know the value of m that makes this true. The question we have to ask ourselves is, does the values of p really matter? M has to be -20 because the dot product still has to be true. And whether they meet at right angles or not has nothing to do with your p and q values. That tells you where they meet or helps you figure out where they meet, but it doesn't tell you how they meet. So p and q can be any value. So are they unique? Of course not. Okay, that's what we do question, the first question, question number 4.